So today we are going to talk about hysteresis, or you might have heard the word hysteresis loop. So in the previous class, in the previous session, we were discussing about what are the types of magnetic materials, like ferromagnetic materials, paramagnetic, and then diamagnetic materials, right? So this is actually one of the important topics which is related to ferromagnetic materials. So when you place a ferromagnetic material inside a magnetic field, so there will be an induced magnetization on the material. Okay, due to the induction. Okay. So the question is, so how does it varies with respect to the magnetizing field and all? Okay. So one thing is very clear that the magnetic induction to magnetizing field, the ratio of magnetic induction to magnetizing field is not always linear. So when you plot a graph against B and H, it's not linear in the case of ferromagnetic material when you place inside a magnetic field. So which is B by H mu, which is not a constant. Okay. So now we are going to talk about, so if it is not linear, then how would it be? So how would it vary with respect to B varies with respect to H or vice versa? Okay, let's talk about that. And for that, first we will consider two loops. So two materials, separate materials, and the loops I have given. So first one is this, and then this one. Okay, let's discuss this one first, then we'll move on to the second one. So actually you might have noticed the difference between this one and this one. Okay, one is a kind of narrow loop, and this is a more of a flat loop. Okay, so let's talk about this. And in this loop, so look at this, there are points I have noted A, so I would like to note this point as B, okay, and B, and sorry, this is C. See, because B is already here, so don't get confused with that. Okay, so this is what is the curve, and the curve is going like this. It's more of a flat curve. So this is the B bar H curve, and three important points which are given in our textbook. That is, first one, the residual magnetism AD. So look at AD. So AD, this is what is residual magnetism. So this much. So the residual magnetism AD present in the specimen is called reminiscence and renditivity. Okay. So reminiscence and renditivity, this is known as reminiscence or renditivity. And then it is defined as the ability of the materials to retain the magnetism in them. Even magnetizing field vanishes. That is very important property. That is reminiscence. Renditivity we also say, but we used to say reminiscence. But the thing is, it is very simple that, like, when suppose at this point the magnetic field is vanishes. So then at that particular time it will obtain, or it will have a magnetizing, an induced magnetic field this much. So that kind of property is known as this one, reminiscence or renditivity, and keep in your mind. Okay, so then you can read that. This is actually more of a theory topic. And one more point it is given: the magnetic field, the magnitude of the reverse magnetizing field for which the residual magnetism of the material vanishes is called coercivity. So coercivity curve is also given here. So which is a coercivity curve? That is AEAC. That is coercivity curve. So AC, this is coercivity, and this is also coercivity. So you can define coercivity and renditivity, two new terms in these curves. So you can, why I have given without writing or without noting any of these points. So I haven't noted coercivity here. I haven't noted renditivity here. You have to do the same. That is why I have given a flat, a empty curve over here. This is just a curve, so you can refer the textbook. You have to note down what are the things or what are these terms. So then finally, what is hysteresis? So hysteresis is nothing but the phenomenon of lagging of magnetic induction behind the magnetizing field is known as hysteresis. So that is what is hysteresis, and I think you have got it. So what is a hysteresis? And there are many terms which are related to hysteresis loop and hysteresis, the phenomenon of hysteresis, and let's talk about that, and one by one. I think this is the introduction. As I told you, this is your work and you have to do that. Okay, you have to refer the textbook and read about that and you will get it. Okay, thank you.